on to section 11.4, volume of prisms and cylinders. So we looked at surface area, where it was the amount of area on the outside of the figure, or if we were to paint something, how much paint would be on the outside, or a wrapping paper type problem. If we were to wrap the figure, how much paper would it take? Now we're going to look at volume, how much space is inside our solids, or our three-dimensional figures. Right? This is measured not in square units, but in cubic units. So, volume of a cube. Since a cube has all sides that are congruent, the volume of a cube is just the side length to the third power. Volume congruence postulate. If cube polyhedra are congruent, they have the same volume. So any congruent three-dimensional shapes have the same volume. They also have the same surface area as well. Volume addition postulate. The volume of a solid is the sum of the volumes of all its non-overlapping parts. So if I do have a weird shape, right, I can chop it into shapes that I know. Kind of like that cylinder and rectangular prism that we did in the last problem on the homework. Cavalari's principle. If two solids have the same height and same cross-sectional area at every level, then they have the same volume. Not necessarily too important for the purpose of this class, but it does come up in some higher level math classes that many of you may take. And then the volume of a prism or cylinder, what we'll be using today, volume equals base times height. So let's see how this works. For this first one, remember a triangular prism, the base is always the triangle. So here I have an equilateral triangle. So I need to figure out my big B. I'm going to use this formula. Volume equals base times height. Height, easy to find. Right? We know the height connects our two repeating shapes. The height right there is 5. But the base is the area of this triangle. So this is an equilateral triangle. So I'm going to use the square root of 3 divided by 4 times the side length squared. I'm going to type this into a calculator. So we get the area of our base. Is 3.9. And now for volume, I just have to plug those two in. Multiply them together. Our volume equals 3.9 times 5. And I get 19.5 cubic meters. Easy enough. Find the area of the base, multiply it by the height. So it's even simpler than surface area. The next one, our volume is still base times height, but our base here is a circle. So that big B turns out to just be pi r squared. So the volume for a cylinder is just pi r squared times the height. Go ahead and try to find the volume of this cylinder. Take a short break. So let's go ahead and plug in our radius there and our height there. So volume equals pi times 3 squared times 4. So volume equals 9 times 4 is 36 pi. And our volume therefore is, using the pi button, 113.1 cubic feet. All right, moving forward. So this one, I'm given the volume and I want to find the side length of a cube. I know the formula for the volume of a cube equals the side length to the third power. So if I take 100 and set the side length to the third power, can I go ahead and solve? This is similar to what you've seen before, where you're taking the square root, but now I'm taking the cube root. So I'm going to take the cube root of each side, which is the same as the square root just to the third power. I'm going to show you a couple different ways to type this into your calculator. We can use what's called a fractional exponent to go ahead and calculate square roots. So, for instance, if I had the square root of 100, that would be 10. The same thing as 100 to the 1/2 power would also be 10. Even though you don't see it, when you see that square root symbol, there's a little 2 up there. So what goes on the bottom when we're looking at a fractional exponent? Whatever's on the bottom, we take the root up, so square root, and then we raise it to the first power. So we can rewrite S as also 100 to the 1/3 power. So let me show you how to type those in your calculator. So taking that cube root, we get a side length of 4.64. All right, let's go backwards. In this one, I want to figure out the radius. So remember the volume of a cylinder? Pi r squared times the height. Here I'm given the height, I'm given the volume, and then I want to solve for the radius here. So we have 4,561 equals pi times r squared times 12. So I'm going to multiply the 12 times pi. And I get 4,561 equals 37.7 r squared. From here, you can divide both sides by 37.7. And I get r squared equals 121. Square root both sides. Can anyone tell me the square root of 121? 11. 11. So this is 11 meters. All right. All right. I apologize for the scary nature of this next problem. We have a cylindrical shark tank. So let's go ahead and create our shark tank here. That's a pretty good shark tank. All right, we can draw our shark tank. Gills. And there's Owen going first. And there's water in there. All right. Now.
Owen's famous question mark.
So now we move Owen and his shark over there. We want to figure out how much water it would take to fill this tank. So we have a diameter of 40 feet. I don't want to use yellow. So I have a diameter of 40 feet. So the radius of this is going to be 40 divided by 2. The radius is 20 feet. And then we're also given the height of the water in here. This over here is 23 feet deep. Can I come up with the volume? Sure. Pi times 20 squared times 23. So I get a volume of 28,902.65 cubic feet of water. Well, we don't measure water in cubic feet. We measure it in gallons in America. So what I'm going to do is go ahead and solve for how many gallons of water it would take. Some of us can see that we just divide it. But remember that idea of proportional reasoning we looked at back in chapter 7. We can set up a proportion to solve for this. Right? I'm given a scale factor. We have 1 gallon over 0.1337 cubic feet. Okay? And then I'm going to put gallons on top over here. That's what I'm solving for. And what my answer was in cubic feet. So 28,902.65. So this is just a cross multiplication problem. So I get 0.1337x equals 28,902.65. And we can divide this up. And I get the water is 216,175.41 gallons of water for Owen and the friendly shark. We'll call him Hal to swim around in. I hope you enjoyed this video. Owen was not actually harmed in the filming.